Alright guys, so let's talk about similarity versus congruence. So I know that these two can be kind of hard to compare and contrast, or they might be easy for some of you. So we need to talk about it in terms of triangles, but first I just want to talk about it in terms of just a general idea. So again, similarity and congruence. So similar or similarity, a lot of you say, oh, then they're similar. And then I get mad at you and say, you can't use the word in the definition. And then congruence, a lot of you are probably saying they're equal. Yeah, but there's more to it. We have to go into depth. So similar, what we've been saying is all of the S's, right? Same shape, different size. Okay? So same shape would mean if you start with a star, you're going to end with a star. If you start with a triangle, you're going to end with a triangle. But different size, whoops, didn't write size. Hello. Okay, but different size means it changed, right? Maybe if you had that star, it got bigger, but it's still the exact same star, it's just bigger. Or you started with this triangle and then you shrank it. Got smaller, but it's still the same triangle. Okay, then with congruence, whoops, it is a lot of the S's as well, but more S's. Same shape, same size. So going back to our star, if we have this star and we move it somewhere, it stays the exact same shape, which is the star, and the size stays the same. Nothing changes at all. So when we're looking at triangles for similarity, okay, let's say we have an equilateral triangle. Okay, equilateral triangle means all sides are equal, all angles are equal. But we have this other triangle, and it's also an equilateral triangle. So you can see this is the same shape, but you can definitely tell that those two are different sizes. When we go to congruence, we have an equilateral triangle, and we have the exact same equilateral triangle. So this is kind of just a picture representation of what you would see. Now this obviously isn't good enough for, high school geometry, because we can't just go off of what pictures look like. We need some measurements. But in the lower, grades, hey, if it's kindergarten day, if you're watching this on Wednesday, this would be good for the kindergarten, right? Kindergartners could definitely tell that this triangle is way bigger than this triangle. They can tell this triangle is the same as this triangle. Now, they don't necessarily understand these symbols, so that's how we get higher up, middle school. So now you guys can understand, it's still an equilateral triangle. These are equilateral triangles, it's just this one got smaller. So similarity, same size or same shape, different size. So then the next thing that we need to check when we're talking about similarity with triangles is we need to have same angles sometimes. Whoa. So meaning their measures stay the same. Measures stay same. I'm getting ahead of myself with my head for some reason. Okay, their measures stay the same. Since their measures stay the same, that is what makes it stay the exact same shape. If you were to change the angle measures, then it's no longer the same shape. That means they're no longer similar. The thing that does change are the sides. So the sides are proportional. So remember, there was always two things that we needed to discuss similarity and congruency, right? We need to talk about their angle measures, which talks about the shape, and we need to talk about their sides, okay? When it's similar, the sides are proportional. Remember that word proportional means fraction, okay? Are the two fractions equal? Sorry, my dog's over here sneezing. So let's say that for this equilateral triangle, the big one, all the sides are 8 units long. And then over here, this equilateral triangle, all of the sides are 4 units. Obviously this is going to work, it's an equilateral triangle, but when you set up the proportion, if I did big triangle on top, little triangle on bottom, I'd have 8/4 is equal to 8/4 is equal to 8/4, which is true, right? They all were, the big triangle was divided by 2. Let's say we change this, and why can't I think? Okay, here we go. So this is an 8, 8, 10, and a 4, 4, 5 triangle. So this changes them into isosceles triangles since we have 2 sides congruent, which will change one of these to 10/5. So again, they all equal 2, or all of those fractions are congruent. Okay, here, in order for them to be congruent, that means they all have same angle measures, and they all have to have the same side measures. Meaning, if these are all 10, then if these are congruent, the other sides have to be all 10. If one of these sides were 9, then these 2 triangles wouldn't be congruent. Everything has to be exactly the same. So congruent is the easy one to check, right? If everything about the angles and the sides are all the same, it's definitely congruent. It's the similar ones that are a little different where you got to do some math. Still super easy to check the angles. Angles have to be the same no matter what, but the sides have to be proportional. That's where you set up the fractions. So the way I always set them up is if I start with the big triangle or whatever the big shape is, I put all the big numbers on top and then all the small numbers from the smaller shape on the bottom, and they have to match up to the sides. So for example, let's go back to similarity. If I have this triangle right here, and I say this side's 10, this is 8, and this is 6, and this is 5, 4, 3. Okay, sometimes it's really hard to tell which sides match up to which because you can't really tell by their lengths and if there's nothing that symbolizes it. So I always just say, okay, big triangle, the biggest number is 10. On the smaller triangle, the biggest number is 5. So it has to match up to the bigger side. Then I go with the smallest number. The smallest number is 6. The smallest number over here is 3, which leaves the middle numbers to go with each other. And as you can see, these are all 2 equals 2 equals 2. 2 equals 2, yeah, that's right. So they are similar. But if one of those fractions doesn't work, it's not similar. So if I were to change this to 6, okay, so now we have these changing a little bit. Okay, so again, 10 goes with the largest number, which is 6. Smallest number is 6, goes with the smallest number over here. Then the middle numbers are 8 and 5. So 10 divided by 6 is some funky number. It's less than 2. It's 1 point something. I don't really feel like doing that in my head. But these are all equal to 2. So since this is not equal to these, then it's not similar. If you see 2 angle measures that aren't equal to each other, then they're definitely not similar. So then, going from there, we have theorems that we jumped into, and that's going to be on your next video. Here we just talked about similarity and congruence, where again, the easy way to say it, similarity, same shape, different size. Congruence, same shape, same size. Congruence being the equal or easy one, everything has to be equal. Similar means it looks like the same shape, but it's either bigger or smaller. So hopefully you can move on to doing the activity that I have for this one, and then next we're going to talk about the theorems that work for similarity and theorems that work for congruence, but we're still just going to stick strictly with triangles for now.